Hi everyone, welcome back. So here's a terrifying example. We have two aircraft that are shown, one with a velocity of 650 kilometers per hour, that one with a velocity of 800 kilometers per hour. Those are their absolute velocities. And you can see that there's a 60-degree angle between the line of action of those two velocities. Your question, will they collide? We can't actually tell though because we don't know any of the distances. We want to find their relative velocity. So how do you do that? Well, there's two ways. Remember, there's two ways. We can break it up into components and then subtract all the components to get our resultant vector, which will be this. Or we can use the graphical method. We can draw each of those velocities as different sides of a triangle and go from there. So what I'm going to let you do right now is I'm going to let you try it out. I'm going to give you a few minutes to try this out. And you come back, you watch the rest of the video and see how you did. So, 3, 2, 1, and you're back. You tried it, you rocked it. You're like, my goodness, Dr. Kid's amazing drawings. The drawing class is really paying off, are helping me so much in this class. Thank you for saying that. However, I still have a long way to go. Maybe I'll show you my sketchbook at the end of the semester. If you all do well. That'll be an incredibly embarrassing day, though. You know what? I'm going to hold myself to that. For everyone, all future generations watching this video, if all of you make at least a B on the midterm, I will show you my sketchbook along with all my crazy doodles and horrible drawings. Okay, it's there. It's in video world. Can't be taken back now. Okay, so let's solve it using the vector method. So vector method, we have to break it up into their Cartesian components. Well, if we're going to make Cartesian components, I'm probably going to say that right is my x direction, up is my y direction. And this one is luckily moving perfectly along the x-axis. So it only has an I component, so 650i. This guy, on the other hand, though, has two components. So we're going to break it up into a triangle and solve for those. As I can see, both of those are going to be negative. So that's 800, that's 60 degrees. And then I would get, okay, well, this is an opposite, or sorry, this is adjacent. This is opposite, there we go. So adjacent over hypotenuse, that's going to be cosine of 60, so 800 cosine of 60. And then opposite over hypotenuse is going to be sine of 60. So this component right here, the y component, would be 800 sine of 60. I plug that in and I get these two values. Now that I have that, I can go ahead and calculate it. And what I'll get is my relative velocity is going to be VB minus VA. And so it's going to be negative 1050 minus 692.8 in the J. Or it's going to have a relative velocity of 1,258 kilometers per hour. You're like, wow, that's a big thing. It is. When you have two jets that are going at each other, you're adding them up. When we figure out the angle, the relative velocity angle, well, that's going to be 33.4 degrees. What is that from? That's from the horizontal. Okay, so that's one way, but now let's do it graphically, okay? We're going to do it the graphical method. So we draw it. We have to draw it so that the point is connecting. Be very careful about how we draw these. Notice that the point is connecting. The tip, that's right. The tail, there we go. Sorry, that's the term. The tail is connecting here. You do not try to do this in the same way you might have seen previously. Let's see, like this. Where it's, tip to tail, tip to tail. If you look back at the pictures for our relative velocity, the tails are always connected. So that's going to help us here. And what is this big angle? Well, that's 60, which makes that 120. And then I want to solve. So I'm going from VA to VB. This is VB over here. This is VA. And then you can see the rest. Now we know one angle, and we know two sides, which is not enough to use law of sines. It could be, actually, if we're careful. This should be an even angle, but it'd probably be easier for us just to use law of cosines, so I don't have to do any more math or trig. So I plug it in. I'm trying to solve for this. I know everything else. it comes to be 1,258 kilometers per hour. And if I use the law of sines, I can figure out what the angle is. And theta will come out to be 33.4 degrees. Okay. Well, that is it for this example. Thank you so much for listening, and I'll see you all next time. Have an absolutely wonderful day. Bye-bye.